All right, everyone. We're back at Smartscope today. Today's Tuesday, April 26th, and we're doing our second test to ensure that we can do a nice broadcast for you on May the 9th of the Mercury transit. So today we've got Wolfram and Jim here setting up Smartscope. We're just doing some calibrations, and we've managed to be able to link our computers so that we can see what's going through Smartscope. Here we've got Wolfram's laptop set up next to mine. So Wolfram's got the Smartscope plugged into this one here, and I'm webcasting on this one. So I'll give you a direct image now of what we're currently getting. We're just trying to work through the focus. We've got the sun in our shot here, and we're trying to get things cleaned up so that we get you a nice crisp image.
Sorry, actually.
Have a seat there, Wolfram. All right, so Wolfram, we're on webcasting right now.
Right?
That's what we see, and need to ask you what's going on right now with Smartscope. Well, what are we seeing right now on this image?
We're looking at an out-of-focus image of the sun with the Next Image 5 Celestron camera, and it's a planetary camera meant for imaging solar system objects. It's not particularly good for stellar and deep space, but it's good for bright objects. And we have a filter in front of the sun to render the sun visible without burning the detector. Now we are attempting to focus it. We have had luck in the past, but we think that the focal point is beyond the position of the detector right now. So Jim is experimenting with pulling it out just a bit further manually, so we can find the sweet spot as to where it should be positioned. And that's why it has disappeared.
Well, that's the whole purpose of doing these tests, is to work out these bugs so that May 9th we can see Mercury going across the sun.
That's the plan. That's the plan.
Now
we wouldn't be using this scope. We're just doing it for demonstration purposes and testing. This is on the D70 smaller, what we call the guide scope. It's not the main 16-inch Meade reflector. The Meade has got a very high magnification. It's very hard for basic test operations like this. You just see a small portion of the sun, and alignment is a little tricky. So right now, for our purposes of testing the electronic setup, the data setup here, the D70 is a much better choice. So that's what we're doing now. The D70 images the sun pretty much in its entirety, whereas with the Meade you will only see a small segment of it. And so it'll be good for tracking Mercury, because Mercury will be a bigger spot. With the D70 it's just a tiny few pixels. With the Meade it'll be a larger, even though still a black spot, but at least you'll be able to see the optical effects and more clearly. So it's still a little bit of a fuzzy ball.
Are there much better sensors available than the Next Image 5, or is that pretty much what's available for us right now?
There are better sensors. Other members of the club have loaned us theirs, and we have a DSLR we use. The D70, as we say, is good for quick video image capture for planetary objects. It's got a narrow field of view, but its setup is easy, and its display is easy. So we like to use it for this kind of thing. But yeah, for proper imaging, you want to use a higher quality sensor, larger size, so bigger field of view, and smaller pixels, and better integration times than this allows. So it's, like I said, good for planetary. It's kind of amateur applications, and it takes really nice pictures of Jupiter and the like. But for serious work, no, it's not the sort of thing you'd normally use, and we do have access to better cameras for that. In fact, we did once have a very nice Orion camera, but we seem to have had an electromagnetic event here, and the USB interface got fried effectively along with the mount electronics a few years ago. So that camera's now been retired effectively, and we're still looking for a new one. But we have Paul loaned us an SLR that we use to great effect at Canon. So is this good as it gets, Jim?
Well, if you follow it, I pulled it out. I unthreaded the connection, and brought it out another inch or so. We could try it again. I'll just do it by hand. Let me know.
Okay, yeah, why don't we do that? Let's see what we can get.
So obviously, for the day of the transit, I mean the transit event isn't something you can postpone. It's going to go through no matter what. We need to get this sorted out before the 9th, so that we got a nice clear image of the sun.
Yeah, well, it gives us about 3 weeks. Well, the imaging problem I'm not as concerned about. I mean, it's more geometry, just getting everything positioned properly. What we have been doing, we were up literally all night, dusk till dawn, calibrating the mount itself to polar align it. So Eric LeMay and Paul Cloginger and Jim and myself were out for that, and we were quite successful actually, because we were having difficulty syncing onto stellar objects. Like it was literally not going where we wanted it to. So we found over the years the polar alignment had drifted a bit. So we corrected for that. And we're going to build a new digital sky model to more accurately position the mount. And with that, hopefully we should be able to zero right in onto Mercury and allow the mount to automatically track it without us having to do manual adjustments. That's the plan. That's been the bit more challenging part. So the optics, I think, it's mostly a matter of geometry, so I'm not as concerned about that.
Is this analogous to back focus on a camera? Like in my field, that would look like a back focus problem, where basically the target's not focused. The telescope's in focus, but the sensor itself is simply not in focus right now.
Yeah, the sensor's not properly placed. Yeah, that's one way to put it. Yeah, the scope. I mean, there's literally, that's what you do. You move in and out for where the focal plane is for the imager, and find where the actual focal plane of the scope is and place in the same place.
Now, what we're looking at here is really it's a video image of the sun that the sensor is putting out at what's the frame rate? About 10 frames per second?
Not even. It's about 6.
6 frames per second.
And the actual sensor is quite large. It's better than high definition. It's actually about 4K. It's 2592 pixels by 1944. So it's quite a large image, and it can't really read out any faster than that.
Now, the real quality of the next image, the trick is to stack several images to get a really high resolution image, isn't it? Like what you're looking at is video, but if you take several shots and you stack them, you're gonna actually get a much higher resolution image, aren't you?
High resolution, lower noise. Actually, that's kind of what it allows you to do. It allows you to bring out the illuminated parts and reject the darker parts that aren't as well, aren't what you want. So yeah, it allows you to do that and basically filter and clean up the image a bit. The converse is longer exposure times, and but that brings out the shot noise and the sensor noise and all that stuff, which you don't want, as well as the black parts that aren't just black.
That's a 2 times barrel on it. I found the barrel.
Oh, you found it?
Yep.
Where'd you find it?
Hanging around.
Okay, well now bring it back in again.
Okay.
Okay, we found a way of extending the position of the camera, and now we're going to bring it back in again. We had it out to maximum extension. Jim found a Barlow to pull it out a bit, and now we're going to bring it back in. Now, Jim, the Barlow has some magnification associated with it, doesn't it? So yeah, we'll be just basically a limb of the sun at this point. Now, the stacking that you mentioned, Eric, doesn't take place in this piece of software. This software is strictly for capture and monitoring.
Okay.
There's keep going.
I hate to interfere with this broadcast, but I'm bringing it back in again.
Yeah, I'm watching it.
Okay.
So that's a separate piece of software that post-processes images that you've captured here.
But you could do that while you're observing. You could stack and
Will it stop?
there we go. We're getting closer.
stop for a second. You can't stack within this software itself.
Oh, so it has to be done separately.
Yeah, it has to be done
Okay.
separately. All you have to
Like you can't have it minimized and then stack with another program on the same laptop as you keep observing.
I wouldn't do that. Maybe a more modern, higher power laptop could handle it. This is a Core 2 Duo, so I don't think it'll have the horsepower to actually achieve that.
That's what it always seems to come down to, is more horsepower.
Exactly right. Just give me a second. I'm adjusting the position there, Jim.
Okay.
Actually, is there still a lens in that Barlow? Because the sun is about the same. The star is the same size, basically, it was before. What's going on here? Whoops. The wrong way.
I think for the day of the event, I'll set up the laptop
There we go.
in another spot, just so
Okay.
we're not. Or maybe we can move the monitor over
Yeah, we'll have a few
and
options.
the mouse, and we can. I'll be more on this side.
Jim, can you move in a little bit more now?
In?
Yeah. Oh, nice. Sweet. Stop. I got a sunspot I can cue in on.
Oh, there we go. Oh,
Just want to get the exposure just where it's nice and clean.
now we're seeing a blotch right here.
Yeah.
What is that blotch?
This little one here?
No, the one to the left.
Oh, that's probably sensor noise. Sensor dirt, I mean, or discoloration.
Oh,
I won't go so far as say
so
dirt, but
we have to clean the sensor.
we actually already cleaned it. It was much, much worse the last time we tried this, so it may need a second attempt.
Could be on the eyepiece too.
Oh, on the Barlow you're using?
Yeah, could be.
You're possibly right, yeah. Okay, well, we'll try something to see if we can get that sunspot sharper. So try in a bit.
Hey. In.
Hang on, wait. No, go the other way.
Out.
Hold it there. Hold it. Are you holding?
Yep.
I think that may be as good as it's going to get for now. I can see now a texture in the sunspot. Oh, how come it's moving? Oh, your hands are off it, right?
Yep.
Well, that's funny. It just moved quite a bit. Excuse me.
Let me try it again.
Hang on. Wait. I'm just moving the scope. Okay, there we go. I think that's about as good as it'll get for now.
Okay.
What we should do is what Paul suggested is, in advance of the event, focus on the moon, get the craters and all the detail nice, because then the sky will be reasonably calm, and we understand about details. There's no detail in the sun except these sunspots to focus in on, but with craters and the like, you can get a really nice sharp image where you understand what you're looking at. And then the next day, the sun same size as the moon, and effectively it's all at infinity. So we should be able to get the same quality of image there.
Now I'm seeing here that the edges around the sun is sort of soft. That's real life. That's what that really is. It's we shouldn't be getting a sharp edge on the sun.
Actually, you would get a sharper edge than that. I think this is atmospheric turbulence right now, and maybe because there was just a bit of cloud cover, so I suspect there's still
Okay, but it's
high
nothing
atmosphere.
optically in the system or in any of the electronics here. It's clouds and other things optically that are affecting the sharpness
That's
of
right.
the image.
Ordinarily, ordinarily you still see a fairly abrupt transition to the photosphere.
Okay.
It isn't fuzzy as you would ordinarily expect an atmosphere to be, because it's still pretty far away. So the transition looks quite abrupt from Earth on this scale. Like if you ever see those prominences and stuff that come in those high magnified,
which we won't be able to see with this imaging. We can't get any.
But when you see them from professional observatories or from satellites and the like, they still show a fairly abrupt but boiling surface of the sun, but it's
Okay.
not fuzzy. And then something rises from a fairly sharp edge. But at this scale, you should see a fairly sharp edge, comparable to what you normally see with the moon. And what I have a suspicion of, if this was a full moon we were looking at, it would probably look similar with this quality of sky out there. So here's the sunspot. And sometimes it actually breaks up into a couple and then it bobs back into one again. So I don't think we're going to get it too much better right now.
No, well, we're using the finder scope too. If we get into the 16-inch.
Oh yeah, no, the beam.
So
it'll be a
so
whole
we're
different-
actually not really using the best available image from Smartscope. We're using the finder scope portion
Well,
of
we're
it
doing it to
Yeah.
test your system.
to test the system.
But
Yeah.
once we get, now we know we can.
So the day of, we'll,
Strictly speaking, we call it the guide scope because there's a smaller finder that the
Mm-hmm.
Meade came with, which has an even wider field of view. But it's like a toy telescope. It's only got about an inch aperture. So this one's a 70 millimeter aperture, and so it's more suitable for transitional astronomical imaging. But yeah, we still use it because of its slightly narrower field of view, but wider than the Meade to do preliminary imaging like this, and test our tracking and so forth.
I'm just glad today we got an image.
I'm glad too. I'm glad I brought my computer in order to make it possible.
And that it's actually working on mine here too. I'm able to webcast directly from yours into here because we're networked, and we're getting a true digital connection, which is also encouraging. But I guess the next thing I'm wondering is when Mercury comes across the sun, are we going to be able to see it transition the limb? Like off the edge, and will that make any difference?
The idea is that we will be able to focus right in on Mercury. Can you see the sunspot here? That's still bigger than Mercury would be. See, they're just bifurcated. Eh?
Yep.
That's definitely an atmospheric issue. It's nothing to do with the hardware here. So when Mercury comes, it'll actually be smaller than this spot. So the idea is to use the Meade, which will have a focal a magnification or image of about this size. So much smaller.
Okay, so Mercury is going to come in. I'm seeing you're using your cursor here,
Yes.
which I'm picking up here, which is great. That's a good way to point
there a
out
bit of lag there?
what's going
Yeah.
on. Yeah. So Mercury is going to come in from the left.
Yeah, and I'm not. I didn't look at the simulations yet, so I don't know where it's coming in. It's
The
going.
specs on, we can find it.
Yeah,
pretty
we'll
easy.
find out.
I saw an animation saying it came in from a little bit higher up than where the cursor is, and
Okay.
it's actually going to go down.
Kind of like this.
Yeah, coming and then go down. Yeah, no, not quite
Okay.
across. It'll actually go more towards the south pole of the sun.
Oh, really? Oh, okay. Well, that'll be interesting. Like I said, I'll have to watch the track. I know for Venus, it tracked it kind of around here, so around the lower
Yes.
third, roughly. So
And it's
I don't
Mercury is going to be a bit smaller than Venus.
yeah,
It's
it's
the-
smaller physically and it's further
Yeah.
away. Yeah.
Venus is the size of Earth, and
Yeah.
Mercury is the size of the Moon.
That's right.
No, good way to put it. Yeah, that's right.
It's a bit bigger than the moon. It's
They
I
make
think
a
it's about
comparison.
what is it, 4,700 kilometers, the diameter of Mercury, from
Well,
what I
that sounds
recall.
about right
I
from what
didn't
I
have my
remember.
tape measure, Eric.
So it would be about maybe 1.5 times the size of the moon.
The books say.
But
size
it's
of the Moon.
about
Yep.
twice the distance of Venus.
Yeah.
So
Yep.
you got two things working against you in terms of the
Yeah.
size.
No, that's good. That's tidy that up. That Barlow extension.
Yeah, and I seem to remember that's what we used in the past.
You know, I wonder where it
Yeah.
was, and I found it on the big
Where-
scope.
where'd you find
it? was
it?
on the big scope.
Oh, was it?
Yeah.
Oh,
Yeah.
huh.
So I took it off the big scope and transferred it onto the finder scope.
Huh. Okay. We've only been using it as an aperture cover so far. So that's where it went to. Okay. Good.
We'll put it back in place after we.
Now, if we had
Anyway,
a
so-
comet going across, would we be able to see it in this image? Like if a comet came in, would the difference in brightness between the sun and the comet be such that we couldn't see the comet?
I suspect not.
It's the Starship Enterprise I want to see go across.
Yeah.
I don't want to see this comet.
Oh, when they go back
do
in
time
time,
travel, yeah, I
time
wanna see
travel,
that.
yeah,
That's what I'm looking
watch
for.
it go around,
Well,
yeah.
you can see we have the current exposure is 1/250th of a second, so it's quite fast, and that's much less than we'd use for imaging a comet for that distance.
When you point out things on the day of, you can use the cursor, because that'll be a lot.
I notice there's a wee bit of lag, so I'll have to...
A little bit, but it's workable.
Yeah.
So tell us a little bit more about this software here. We're seeing a lot of information at the top of the screen here.
Well, this is software that came with the Celestron Next Image camera. They call it ICAP 2.2, and it's basically a imaging software for that camera. It pretty much is optimized for that camera. It actually looks for other cameras, so imagine it could work with others. We've never tried. We always used it in association with the Next Image, but it does both video, which is what it's configured with now. You can actually see up here where I'm putting the cursor, little icon of a video camera. So that allows essentially live capture, though we use the term video loosely. What it really means is live refreshed capture. Currently it's going at about 6 frames per second, so of course video is 30 to 60 depending on how you look at it. So it doesn't do that, but it refreshes at whatever capture rate the
it wouldn't be necessary to have a higher frame rate anyways.
No,
because there's nothing on the image that's moving very fast.
Quickly. You're absolutely right about that. It's more of a comfort level that you're accustomed to image refresh, and also if you're making adjustments as we just did with the focus, you to do that comfortably, effectively, usually want a faster frame rate. Now we could speed it up. What this software allows is you to control the camera to capture data from a smaller set of pixels, basically zoom in on a smaller area of the detector and only read out those parts. So since it's reading out less, it can go right down to VGA limits. So putting it on the cursor here shows the frame sizes available. So it goes all the way from VGA, which is 640 by 480, up to this maximum of the full detector, which is 2592 190.
Can we try that for a second? Just go to
we can go to the VGA. I'll take it right down, and you'll see it's a smaller image because literally it's taking a smaller portion of the detector. You can demagnify that, so make it bigger.
Now we're just getting oh, I see.
So you can see we're right on the sunspot.
Wow.
As luck would have it, here's the sunspot, and it literally, it does not, when you do that, shrink the image size of the full detector. It literally takes less pixels of the detector to read out. So hence, right now we're running at a 25 frame per second frame rate. So it's trying to optimize the exposure and gain in order to get for a suitable frame rate, so it'll go as fast as it can. So basically it's sped it up. So we're at 25 and at a smaller image size.
Now the sunspot is moving a lot. That's atmospheric turbulence.
Absolutely, yeah. That's right. It's normally
there wouldn't be any motion introduced by Smartscope itself.
No, Smartscope's actually quite good. As you observed, it's on a concrete pedestal all the way down to bedrock. It's physically isolated from the observatory. There's about a 5 centimeter gap all around, so the floor does not interact with the scope. So and the ground here is quite stable. There's no roads or frequently used roads, I should say. We do have.
What about earthquake tremors?
Well, you would see that if we had some, but fortunately Ottawa only gets an earthquake every couple of years. I was here during the last one, so but normal tremors, no, you wouldn't be able to see them here. They'd need a proper device for that. So yeah, the scope itself is actually quite solid. We were doing sub-arc second tracking just on the weekends, Saturday, Sunday, overnight, and sub-arc second, that's like literally less than a pixel on the next image we were tracking, and those stars were rock solid. So if there was any physical tremors, they would be bigger than that. And this thing's moving many pixels, so that's a dead giveaway that we're looking at atmospheric effects there.
Now I noticed there aren't very many sunspots in that we're seeing in our image today. Is the sun at a low period of sunspots right now?
Actually, I think we're in a transition right now. I don't think we're in a minimum and we're not in a maximum. I think we're in a transition because I think there was a minimum just recently. Now,
so we're going back up.
I'm a little bit rusty on my solar dynamics right now, but I think we're in a transition.
So we're basically starting a new 11-year period.
Yeah, we're somewhere into the rise. I believe we're in the rise for
Rise,
11-year period.
okay.
Because there was a concern that the sunspots had been less common for a fairly long period. So people were actually talking that maybe there might be a new moderate minimum happening. But then we arose out of it. So I think we're still in that rise. I may be wrong, but that's what I seem to remember.
Okay, can we go to another resolution? Let's see what...
We can go bigger if you want.
Yeah, let's go
this
bigger.
This is the absolute minimum.
Uh-huh.
So the next step up is here. And so okay, you can see a bit more. Just magnify it a bit. Make it a bit smaller so that the image fits. So we're now at 1024 by 764. So that's getting almost towards high definition type quality.
Now, when Mercury goes across, there won't be any detail available of the backside of the planet. We won't. There wouldn't be. There would be too much contrast to be able to.
Just a spot.
It would just be a spot.
Absolutely right.
And so when we observe Mercury from the Earth, there's really no way to see any detail of the planet's surface, is there?
No. Even the best ground-based observatories, well, Mercury is on the side of the sun, only observed blurry features. I remember that when the Messenger probe went to orbit, they often showed its images contrasted to the best images from Earth observatories prior, and it sort of showed what geological features were probably being seen from Earth, contrasted to what the spacecraft can see. So they were always very blurry. A lot like those early pictures of Mars that Herschel used to take, where he thought there were canals and stuff. So it's a lot like that, and it's further away, and as you said, it's much smaller, and it's never that far from the sun, so the seeing is never that good. So you got a lot of things working against you to be able to get a decent image of it.
Okay, why don't we try another resolution here?
Yeah,
See
we'll
where.
just keep going out. The next one.
Yeah.
I'm just wondering. This one is almost. Yeah, this one's your conventional HD TV type resolution. So this is 1920 by 1080. So this is your conventional high definition, non-broadcast high definition, the type you get from a Blu-ray disc. So that's what you get there. So we're getting better. Still a little bit fuzzy, but as we said, the atmosphere is working against us. We've seen the sunspot kind of wobbling like jelly. So that's a
now this spot here. If you want to point the cursor, this
right
spot
there.
Here, that's not a feature on the sun.
And
That's a smudge of some kind.
Smudge of some kind.
And we
That's
can't
right.
seem to be able to get rid of that.
Not today. We'll probably have to apply some alcohol to the surface detector. Or, as Jim pointed out, we do have a Barlow in there to provide as an extension to. There may be some staining on that.
Now, we're looking through the finder scope. So with the actual Smartscope, the day of, we're going to get a much better image still of what we're looking at here.
You'll get a much closer image. That's right.
A much closer one.
Because the Smartscope has a very long field of view, so it naturally provides a more magnified view of whatever it's looking at. So it's quite good for deep sky objects, and even for planetary imaging, you get a very nice big image of Jupiter and the like. When you look at the moon and the sun, though, it's very magnified. Looking at it,
so we won't see a whole picture of the sun with Smartscope.
You'll see about this chunk like this. You know, actually, it's not much bigger than one of these blobs that you were referring to. It's sort of on that scale of magnification. You can see an arc of the limb of the sun, so you can make out an arc. So clearly, it's probably about, a little segment, maybe 20% of the width of the sun. When you look at the moon, for instance, a crater like Copernicus takes up a lot of the field of view in the Meade when using the next image. So it zooms in quite a bit, just its natural magnification.
So Smartscope, we won't be able to see the whole sun. It's just not designed to do that.
Correct. That's correct. Yeah, we won't see the whole sun. We'll see
But the trade-off,
fraction of
you get to zoom into a much closer
Yes.
image of things, and that's what you want.
We felt that for the transit of Mercury, it would be better to use the large scope because of its magnification. In that case, you would see Mercury kind of on the size of this sunspot here. So it'd be, on this scale, but Mercury will be just a few pixels wide, maybe 10 or so. Whereas on the Smart Scope, it'll probably be in the order of 30 or more. So you get, at least you get a better feel for what you're looking at. It doesn't look like just a pinpoint. It'll actually look like a circle going across the sun. And there's apparently some interesting limb effects if the seeing is clear. Like it'll look like it'll optically merge like a droplet almost.
And that's what we want to see.
Yeah, we want to see.
At the beginning of the transit is that moving across that limb.
Exactly. Yeah, that's right. That's the excitement of it. Is you get those interesting optical effects where it seems to blend in with the limb, and then like a droplet break away from it.
And those are things you wouldn't see at a lower magnification. Like if we had the whole sun in the image, you wouldn't see that.
And that's right. As I said, it's only a few pixels across, and that optical effect is even smaller. So it might be a pixel or two. So you wouldn't even know what you're looking at necessarily. You might easily miss it. So ideally, we'd be able to see more fine detail like that.
Now this is going to start at sunrise, approximately. The transit's
Oh, actually,
be,
I wasn't even aware when it was happening.
Yeah, because we need to make sure everything's working and we're ready to see the sun come up and the that point where we actually start seeing Mercury coming into the field of view with the sun. That'll be happening around sunrise. Won't it?
Interesting. I've been focusing so much on the day, I didn't even look at the specific timing of it. It's 6:30. Well, 6 in the morning. That's about the sunrise is around 6.
And Smartscope doesn't have any problem pointing that low.
Oh no, not at all. In fact, when it's parked, it's actually looking below the horizon, so physically it can do that.
Oh, okay.
Yeah, I park it low in order to prevent dust from accumulating on the main optics and the like.
Okay.
No, it has no problem with that at all. In fact, I've looked at the horizon in order to adjust focus on trees and the like. When doing daytime work. So it can handle that.
And
but the seeing's not the best at that time. That's my one concern with that. Because we can see the sun is now high. What do we got now? 140. So the sun's quite high, and that's about when the atmosphere is thinnest. So if it's at dawn, you're looking through fairly thick atmosphere. So that's not the best seeing. So
we're gonna have the moon available as well. That before the sunrise.
No, I believe it'll be just after.
Okay.
Because I just looked at that. It'll be at an early crescent, so a rising crescent. I mean, a setting crescent around that time. So no, we won't.
Now we're very fortunate that in North America we'll be able to see the whole transit, and I've seen a map that shows the area of the Earth that can witness the whole transit. The transit's going to take about 7.5 hours.
Oh well, okay. Then
from
part of
start
it we'll
to finish.
see. We might miss the beginning in terms of quality imaging, but that means it'll be done around noon. So we'll be into this kind of imaging quality later in the event. Yeah,
right now it's 1:40 p.m. So this is where we're getting at this time of day. But that doesn't really change from the point of view of looking at the sun. What time of day you're looking at it as, it's the brightness of the sun doesn't change that much from sunrise through midday through sunset.
Just whatever the sky,
whatever the atmosphere
permits,
is doing. Yeah, exactly. I guess what I'm wondering also is let's say if a satellite was going in front of right in our field of view, that would be pretty lucky for that to happen. But would we see it?
Unlikely to see anything but the space station. Space station you can see. It comes out about as big as that sunspot again. I've seen pictures of it as a space station transition across the sun. Satellites are quite small. I mean, satellites are about the size of this room, except for ComSats, which are 40,000 kilometers away. And those would be specks, if you can see them at all. But space station is low and it's big, so...
You're saying at this magnification, if the space station happened to fly by in our field of view, we would see it.
Yeah. We'd be quite see it. We'd probably see the full structure of it with solar panels.
Wow.
And
Well, I've seen those images. I just didn't know we could do that with this.
Yeah, no, it did. On the scale of the sun, I've seen the space station transition photos, and they're about the size of that sunspot. So they, should should be quite clearly visible. But it's a rare event. It's
well, you have to
rare enough that it's noteworthy.
Yeah, and it has to go right down the. I mean, that's a very small field of view there too. So
actually no, this is not small. This is about half a minute. This is the moon. So no, not half a minute. Sorry, half a degree or so.
Half a degree.
Yeah. So it's about the size of the full moon. Like right now.
So that's actually a large field of view.
Comparatively large, yes.
Okay, compared to looking at, let's say, the Crab Nebula.
Well, the Crab Nebula is considerably further away.
Be further away, but it would also be in a smaller field of view than looking at the sun.
You might see an eighth of the limb on one side with the Smartscope set up.
Well, this is great. I'm glad we've got this going. I was most concerned about
you can see the
interfacing our computers.
It's doing this again. So clearly, I think that's about as good as it's going to get.
Well, you're looking at glass lenses too, or plastic lenses too. I think in the 70mm. Not the very best.
Okay, can we go to the maximum resolution available?
This is the maximum.
That's the maximum there? And what is that resolution?
2592 pixels by 1944.
That's as good as it gets.
Yeah, that's almost a 4K type image, almost, just shy.
Mm.
And we're back to 6 frames a second, 1/250th of a second exposure per frame.
Now, if you were to lower the frame rate, could you improve the image?
Let's give it a try here. It'll make it a little darker, but I doubt it'll get too much better. Because right now this is about as fast as it can read out, so visibly it's not going to improve that much. See, now we're at 1/1600th of a second effectively.
1/1600th of a second is your shutter speed?
That's the shutter speed.
Okay, but what about frame rate itself? Because we're at
frame rate, that's limited by the readout rate of the whole detector. As I said, this is pretty much a 4K quality image right now, and it just cannot get the bits down the pipe fast enough to run faster.
Okay. And if we go the other way with the shutter speed, let's increase the shutter speed.
Yeah, we can get brighter. So here's back to the 1/250th. About 1/100th. See, basically, it just keeps getting brighter. That was.
And that obviously affects what details you can see.
Yeah.
Now we've washed everything out, so you want to lower your shutter speed again so that you're actually increase your shutter speed so that you're not getting as much.
Actually, I was wrong before. I think we were not 1/250th. Or maybe we were. Let me just see. We were 1/1250th. Sorry.
Well, that's what I was wondering.
Yeah. Well, 250th. It's pretty decent, respectable, fast speed. But no, I missed that 1/1.
The sun would be the only object that you would use that shutter speed at.
The moon sometimes too. It can be quite bright and you're full. So you often want to go pretty sharp fast on the moon. Well, you remember we are using a Mylar filter in front of this.
Yes.
So when we first brought the image up, it was almost black and it was very dark. So we were very underexposed. Like this is manual adjustment too. When I go to auto, it actually it's not too bad right now. It's going a little bit brighter. That's. Bring it back a little crisper. There. Maybe a little brighter than that.
Well, I'm just tickled that this all works. That was my big concern the last couple of weeks
That's
is
an interesting
to see
solution, yeah.
how this all works. And I knew Desktop Presenter would be the way to go because Chris and I use this same setup when we're webcasting.
So how's the data chain going? So we definitely get the imaging here, and then through Desktop Presenter, I'm talking to your computer here.
That's right. What's happening is we are we're linked basically through the local area network through the same internet hub, and Desktop Presenter is sending the image to mine through that link. I don't know all the inner details of how that works, but what it's doing is it's giving you a true representation of your display onto my computer. And
then from your computer, you're broadcasting out to another server somewhere.
Right now, I'm webcasting to the Ustream server, which is in San Francisco. And they're distributing it from there to whoever logs in live. Now there is about a 30-second delay. So if you were looking with your smartphone at what we're doing right now, you could see us in there, but it wouldn't be a live image coming back. It would be a delayed image, about 30 seconds.
All right, well, that makes sense. There's a lot of distances and...
well, it's got to go through servers and networks,
involved,
and it's buffering as well. They have to process the image to get it out. There's a lot of compression going on as well because there are literally millions of people using Ustream now.
Are there?
Across the world. And
this is what we use for our meetings as well.
Our meetings are webcast through a Ustream. NASA uses Ustream.
Oh, really? Okay.
It is. I mean, there are other platforms available. Like you can use Livestream, which is with YouTube, and there are others that I've looked into. But I found that Ustream, because it's so universally used, that's the one I decided to do webcasting with. And I haven't seen a big quality difference between Ustream and the other services. So part of it was stealing the Ustream name because NASA uses it. Figure, well, if it's good enough for them, it's good enough for us, or vice versa. So we use Ustream, and anyone in the world can watch what we're doing right now. That's and as many people.
Careful, Wolf.
As you want.
We're celebrities now.
Watching. Well, we're famous. Yeah, like Chuck says, we're
better
famous.
get my facts straight. This is 1/1000th of a second. I got that straight.
So the idea now is we'll be able to while people are like, for example, the RESC is having an outreach on Parliament Hill.
When?
On the 9th during the event.
Oh, really?
Yeah. So what they'll be able to do is they can look at it through their telescopes, but then they can also refer to ours.
Yeah, they can send their whatever device they're carrying.
And maybe if they don't have the ability to, I mean, I doubt there's a telescope that's going to be on Parliament Hill that'll be as good as Smartscope.
It'll be quite an accomplishment to bring something bigger.
Yeah, to bring something bigger over there. So we'll be able to bring that to them, and they'll have the benefit of seeing it through Smartscope very conveniently on their mobile device.
Yes.
And we've already posted a link on the RESC website, stating that we will be webcasting.
Okay, so
we're also recording it so that anyone who wants to watch everything that we did today, they can just go to the website.
Right.
And watch they can skip ahead to further on in the transit, wherever part they want to go to.
Sure.
I can do 3-hour intervals. So every 3 hours I have to stop the webcast and then start it again. Because there's a 3-hour limit to the recording. Is
that a restriction of your subscription?
It's the way the server works. That you can do 3 hours. You simply log off for a minute. And then start it up again. You're good for another 3 hours.
Oh, okay.
You just can't record.
Well, since it's a 6-hour transit, you said it will require at least one of those.
Yeah. Awesome.
And you notice we haven't really touched the telescope position at all. So the telescope is tracking quite effectively. So our task on the weekend seemed to work out well.
Yeah, I noticed that it's the tracking is perfect.
Yeah.
You couldn't tell that it's moving across the sky.
No, it's moving really well.
The dome's not hooked up.
We have an issue with the dome, but we'll resolve that.
That's fine.
But the scope is the critical thing. Is that you want to keep it smack in the center, and when it will track planets as well. So when we lock onto Mercury, it will track Mercury across.
Do you have the capacity to record the event on your system as well?
We do actually. It has an ability to record here. It's not something I've explored much. We have taken still exposures, but you can. There's a drop down to see to do recording. In fact, used that in the past to take a few exposures of Jupiter and well, it's Jupiter and the Moon. Yeah, of course, some interesting lunar images we've gotten.
We'll have to come out and hook up the big scope and check on the lens quality.
Yeah.
All right, folks. We're gonna log off for now, and that today was a successful test of our system, and we look forward to seeing you on May the 9th. So tune in. We'll be starting live early on. It's Monday morning, May the 9th, and we want to share everything that's going to be happening with you. So we hope you tune in. Until then, Eric Kujala from the RESC, wishing you clear skies.
We're celebrities now.